Hello guys, welcome back to my YouTube channel. Today we have a very nice and challenging exponential equation before us to solve. And to solve this, we are going to be applying some already established and known rules and tricks in math. For example, the rule on the law of indices, operating laws of indices, and the rule on the factorization of cubic trinomial. And then of course, we are going to look at the rule or law on how to apply logarithm to solve certain challenging problems. Okay, so today, if today is your first time of coming across my YouTube channel, please, I want to appeal to you to subscribe, give me a like, comment on this video, and then of course share the video with your friends and colleagues. Okay, so that's said and done. Let's look at this question. How do we solve it? I'm going to be using a kind of an approach that is different from what you have been seeing everywhere on YouTube. Okay, so the approach today is that you just follow me and see what we do here. First, I put down my solution. 2 to the power of a plus 8 to the power of a equal to 130. So the first thing to do is to first of all look at this question and see what is the lowest common base. The lowest common base is 2. And because this 2 is to the power of a and 8 is to the power of a, so both are written in exponential form. The 130 is written in an ordinary form. So the major challenge in this question is to deal with the terms written in exponential form. We start with 8 because already we've been able to establish now that the lowest common base is 2. Okay, so I'm going to write 8 in power 2. And the way to do it is to look at 8 as 2 times 2 times 2. That will be 2 to the power of 1, 2 to the power of 1, 2 to the power of 1. That is 2 to the power of 1 plus 1 plus 1. That will give us 2 to the power of 3. That's 1 plus 1 plus 1 is 3. Okay, so once that is done, because this stems from the fact that a to the power of n times a to the power of n times a to the power of p will give us a to the power of m plus n plus p. So this is very important, okay? So we apply that here. And therefore, the next line of the equation becomes 2 to the power of a plus 2 to the power of 3 all to the power of a equal to 130. And then here, I'm going to go ahead and use another rule of indices that says we have a to the power of n times n. That we have the base of the number, a certain base raised to the power of 3 and then to another, so we have a product of power here. So this will give me, I think what I should have is a to the power of m. Okay, so this will give a to the power of m times n, which is the same thing as a to the power of mn, and can also be written as a to the power of n to the power of n, because I'm trying to switch places to reverse the order of m and n, just like we are going to reverse the order of 3 and a. So the a comes in and then the 3 goes out. So we have 2 to the power of a plus 2 to the power of a all to the power of 3 equal to 130. And then from here I can make a substitution. We use a variable different from the variables we have in the original question. Okay, I'm going to look at a variable that I have not used. So I'm going to look at p. So let p equal to 2 to the power of a. So anywhere we see 2 to the power of a, we simply put in p there to reduce this exponential form to a simple a simple cubic trinomial. And then we are going to have 1. This will give us p plus p cubed equal to 130. And then I can rewrite this to give me p cubed plus p minus 130 equal to 0. So this is our cubic trinomial. these are cubic trinomial. Therefore, we need to find the factors of this cubic trinomial. It's either this is going to have 3 linear factors or 1 linear factor and a quadratic factor. Okay, so, and the way to look at it now, to get those factors I just mentioned, we can do that by simple factorization, which is common. We can also do that by using division of polynomials. Like we all know, this is a cubic trinomial, so I'm going to use the division of polynomial. But before we look at that, let me quickly say there is a very important thing we need to take cognizance of, which is the 130. So we have 130, which can give us plus or minus 5. Let me start with 10 times plus or minus 13. Okay, 130 can also give us plus or minus 5 times plus or minus 26. So let's look at the combination of these factors. So in that case now, I'm going to get 4 linear factors from here, which are p plus, because our variable here is p, we're going to get p plus or minus 10, p plus or minus 13, p plus or minus 5, and then of course p plus or minus 26. So these factors, we are going to test to see which of them will factorize or will divide exactly into this cubic expression or cubic equation. So let's start with the first one. So, and to start, what I'm going to do is to plug in, is to substitute these factors into the equation. First we have p cubed plus p minus 130 equal to 0. That's our equation. So let's start with the first factor, p plus or minus 10 equal to 0. So I'm going to use p plus 10 equal to 0. So here I'm going to say p equal to minus 10. First, let's use p equals to minus 10. So we have minus 10 cubed plus minus 10 minus 130 equal to 0. Let's see if that will give us 0. This is minus 1000 minus 10 minus 130. This is not equal to 0 because the left hand side is going to give us minus 1140 equal to, is not equal to 0. So I think this rules out this. Now let's try p. Obviously, since p equal to minus 10 didn't give us 0, that will also rule out p equal to 10. P minus 10 equal to 0. So p will be equal to 10. And then when we make the substitution, this will give us 1000 plus 10 minus 130. This cannot be 0 as well. So this is not equal to 0. So that, this one is ruled out. And since p is, we have tried p plus or minus 10, p plus or minus 10, and the result is not equal to 0. And by implication, since 13 is numerically greater than 10, so this is also not going to give us the answer. And same thing goes for p plus or minus 26. The only option left is p plus or minus 5. So we are going to try those and see what we get. Let's try, we have p cubed plus p minus 130 equal to 0. So let's try p plus or minus 5 equal to 0. First, we are going to try p plus 5 equal to 0, so p equal to minus 5. So let's try p equal to minus 5. So we have minus 5 cubed plus minus 5 minus 130 equal to 0. This is minus 125 minus 5 minus 130 equal to 0. So this is minus 260. And this is not equal to 0. Let's try p plus p minus 5 equal to 0. then p equal to 5. So we have that will be 5 cubed plus 5 minus 130 equal to 0. 125 plus 5 minus 130 equal to 0. Then 130 minus 130 equal to 0. So that means 0 equal to 0. So our only factor that will factorize into this, that's a linear factor of this, is actually p plus 5. So now what we are going to do is to now come over here and divide let's try to divide. So we have p cubed plus p minus 130. We divide that by p plus, we divide that by dp plus 5 or p minus 5. Let's divide that by p minus 5. P minus 5. So I'm going to introduce 0p squared here, okay? So as to make the division less confusing. Okay, so p divided to p cubed is p squared. P divided to p cubed is p squared. Then p squared minus p, that gives us p cubed. P squared times p gives us p cubed. P squared times minus 5 gives us minus 5 p squared, and then we minus that. This and this will cancel out, so this will give us 5 p squared. That's minus now. Minus times minus is plus here, so that's 5 p squared. Then you bring down p. So p divide into 5p squared, that will give us 5p. 5p times p will give us 5p squared. 5p times minus 5 will give us minus 25p. So once we subtract that, this and this will go. Minus times minus will give us plus. So plus 25p plus p will give us 26p. And then of course we bring down minus 130. P divided into 26p will give us plus 26. 26 times p will give us 26p. 26 times minus 5 will give us minus 130. So everything here will be 0. So this cubic equation becomes, so our quadratic p cubed plus p minus 130 equal to 0 becomes p minus 5 times p squared plus 5p plus 26 equal to 0. Yes, equal to 0. So we need to find out if this quadratic expression is also factorizable. And the only way to do that is to use the discriminant of a quadratic function. What is the discriminant? The discriminant of a quadratic function is that value that shows to you, or that property that shows to you whether a given quadratic function has linear factors. Okay, so, and the discriminant is written as d equal to b squared. The discriminant is written as d represents the discriminant, and then equal to b squared minus 4ac, where a, b, c are variables or constant in this particular. So let's look at that quadratic. P squared plus 5p plus 26 equal to 0. The value of a will be 1, value of b will be 5, and the value of c will be 26. A is the coefficient of p squared. Here, the coefficient of p squared is 1. B is the coefficient of p, and c is the constant value. So let's plug in this into the discriminant formula. Let's see what we get. So that will give us d equal to b is 5. So that will be 5 squared minus 4 times A, 1, times the value of C is 26. We have 25 minus 4 times 26. What would that give us? That's 52 plus 52. That's 104. So we have 25 minus 104. That will give us, this is 9, and this is 79. So that's minus 79. And the rule is that if D is greater than or equal to 0, then there are linear factors. Then this will have the roots are real. There will be real roots. But if D is less than 0, there will be imaginary roots. And then looking at 79, 79 is not a perfect square, okay? So 79 is not a perfect square. Therefore, the imaginary root, we just leave it there. And then, meaning that this p squared plus 5p plus 26 is imaginary. There is no real value. Therefore, from here we can conclude by saying that p plus 5 times p squared plus 5p plus 26 equal to 0. So where p plus 5 will equal to 0, or p squared plus 5p plus 26 equal to 0. So from here we have p to be equal to minus 5. And then p squared plus 5p plus 26 will have no solution. This particular expression, no real roots. And therefore it will be rejected. Because this has no real roots, therefore it will be rejected. Sorry, this is minus. Sorry. This is minus, and therefore this will give us plus. So the second part from what we've just done is an imaginary, we have imaginary roots. Therefore we just reject it, and then we stick with p equal to 5. Okay, now let's put an end to this problem. So let's put an end to this problem. So we are going to say since p equal to 5, and then we have said that p should be equal to 2 raised to power a. So what do we have? So it's going to be 2 to the power of a equal to 5. And then we take logarithm of both sides. Take logarithm of both sides to base 10. Or just say take logarithm to base 10 of both sides. It's the same thing. So we are going to say log 2 to the power of a to base 10 equal to log 5 to base 10. Now there is a rule in logarithm that says if you have logarithm of m to power x base a, this will give us x. The x becomes a coefficient of the log. Becomes a coefficient, so you have log m to base a, log m power x to base a, or log to base a of m to power x. This will give us x log m to base a. So this rule applies here. So the a becomes a coefficient of log to base 10. You have a log to base 10 of 2 equal to log to base 10 of 5. So let's divide both sides by log to base 10. Log to base 10 of 2. So we have, dividing both sides, we have a log to base 10 of 2 divided by log to base 10 of 2 equal to log to base 10 of 5 over log to base 10 of 2. So this and this will cancel each other out, and then we are going to have, what we are going to have now would be, a equal to log 5 to base 10 over log 2 to base 10. Log 5 to base 10 is, let me check that, I think 0.6. Let me check that. Log 5 to base 10. That would be, okay, so degree. Okay, so degree. Log 5 to base 10 is 0.690. Divided by log 2 to base 10 is 0.3010, and that will give me 0.6990 divided by 0.3010. That is going to give me 2.322259. 2.322259. That is nearly, it's an approximate value, it's not exactly. That depth, so we can compute to say that A is nearly equal to 2.32259. I've given my answer to 5 decimal places. 5 decimal places, okay? So for better accuracy. So I've given my answer to 5 decimal places for better accuracy, okay? So what we now have is that I'm going to check this now to say we have 2 to the power of A plus A to the power of A equal to 130. Let's check it and see what we have. Check. So that will be 2 to the power of 2.322. I think it's 2 points. How many 2's do we have there? Okay, I think that will be 259. 259 to 6 decimal. Sorry, 1, 2, 3, 4. Yes, 6 decimal places. So 2259 plus A to the power of 2.322259. Let's see what that gives us. So I'm going to say 2 to the power of 2.32259. That will give us 5.0011. Then we have 8 to the power of 2.32259. That will give us 125.086. So at the end of the day, we're going to have 130.08611, which is nearly 130. Okay, so I think this is correct, right? This is actually very, very correct. So guys, there you have it, the solution to this to the equation we have. We've been able to prove, solve to obtain a value of 2.32259, and then we'll check that by doing substitution to get the actual value of 130. So there you have it. Thank you for staying by, and I promise you that in this channel I'm going to be giving you the best of math tutorials, math challenges that will help you in your math journey. Either you are sitting for any exam, any international exam, whether the IMO or the IGCSE or SAT or CAT, everything will be covered in this channel. So just encourage me by subscribing, liking my videos, share it, and then of course give me a comment, and I will see you in the next class. Thank you.